So now we're verifying inverses. So given two graphs, we need to tell whether or not they are inverse of each other. So by looking at it, we can clearly tell that this is a reflection of that. So I can clearly say and easily say that yes, they are inverses because they reflect across the line y equals x, which is this line right here, and they also intersect that line. So this is a good way to tell. So it looks like it's a reflection, so they are for sure inverse of each other, and they intersect at that line. So now we have two functions right there. I need to tell by graphing if they're inverse of each other. So I'm going to go ahead and graph dark blue with dark blue. This one is f of x. And light blue. This is g of x. So it kind of looks like a reflection, but the main thing is they do not intersect at y equals x. When you're in doubt, the one thing that you can look for is, do they intersect at the y equals x line? And the answer here is no, they do not intersect at the y equals x line. So far, super easy.
All juniors and seniors, please go to the Commons for the Dress for Success presentation.
So if functions f and g are inverses, then the composite, okay, let me start from the beginning here. What we're going to have to do, we're going to plug in g for x, and then hopefully it will give me equals x. And then we're going to plug in the function f for g right there. And if it comes back equals x, then they're inverse of each other. You're looking at me like, what? So here we go. The first thing I'm going to do, I'm going to plug this in. I'm going to plug in g for x on the first one. So I'm going to do this 2 is this 2. I'm going to substitute function g for x right there. And I'm going to keep on going with my function. Plus 4. This is function f, but I plugged in g for x. So 2 times half is 1. 1x. 2 times 2 is 4. And then the plus 4. These 2 go bye-bye. So the composition function is equals x for the first one. Now I need to check the other one. Nobody likes fractions, so I'm just going to make it a 0.5 instead of fraction. And I'm going to replace the f of x function right there for x. And then I'm going to move on with the g function right there. This one is this one. This x came from f of x. This whole function is right here, color-coded. Distribute that. These 2 go bye-bye. Now that I got my composition function for both of them being equals x, that means these 2 are inverses of each other. So the answer here is yes, they are inverses. The other way you could have done you could have literally just done what we've been doing. Where you see y, you're going to write x. Where you have x, you're going to write y. And then you're going to solve for y. When you solve for y, you should have gotten this function. But then you got to check both ways. But this is another way to do it. Whatever is easier for you. So now I need to check if number 4, if these two are inverses of each other. I'm going to do the same thing. I'm going to do the composition function. I'm going to start out by plugging in g for x on the function f. So I'm copying here my function f, cubic root of x, and I'm going to substitute g right there for x. And then minus 6 for function f. I know that these two are inverse of each other. I have x minus 4 minus 6. I have x minus 10 when I was expecting to get equals x. So my answer here, I don't even have to waste my time and try to find the other way, because for them to be inverses of each other, both of them need to check. If this one already doesn't check, I can stop right here and I can just go, hey, no, they're not inverse of each other. Last one. In example 5, I got, while I was working on IXL, I think I was at 74. So when I was working this out, the first thing I did was to change from fraction into decimal, just because it's just easier to deal with decimals. So I'm going to plug in g into f. So I'm starting with f. I'm going to plug in g for x. So all of this is x. And then I close parentheses and then I cube it. All of this is the same, and this is the replacement for x right there. And then minus 8 and cubed. I will distribute this 2 right there. So this 2 is going to stay the same, and I'm going to keep the parentheses right there. So distribute the 2, the negative 2. Negative 2 times 0.5 is 1. Cubic root of 0.5 of x. Distribute this negative 2 with this negative 4. That is plus 8. And then bring this down, minus 8, cube it. Before I distribute this 2, I'm going to try to get rid of this cube right here. Positive 8, negative 8 cancel out. Cube and cubic root cancel out. Now I only have this 2 left and 0.5x left out. Now look at that. 2 times 0.5 is 1, 1x. So we're going in the right direction here. And it's hopefully, if the other one checks out, they will be inverse of each other. It's looking good. Now I'm going to do the g function, and I'm going to plug in f into x right there. The reason why I use brackets, not parentheses, you can use parentheses, but just so I know which one belongs to what. And then -4 right there. So all of this in dark blue is x from function f, and everything in light blue is from function g. I'm going to distribute this 2 right here first. I'm going to leave the point. No, I'm going to multiply these two. 0.5 times 2 is 1, so I don't have to worry about 1. It's one less thing I have to worry about. I'm going to leave that thing alone. The root ends right there. And then -4. Oh, look at that. These two cancel each other out, and I'm going to distribute this -0.5. I'm going to write it down because I don't want it to be messy. This is still left over from function f. Now I'm going to distribute the 0.5 to everybody inside the parentheses. 0.5, -0.5 times -2 is 1, so 1x. -0.5 times -8 is +4. Oh, look at that. So composition function for both of them turned out to equal x. That means they are inverse of each other. Because the composition function, they both came out to be equals x. So that's a good day at the park. So IXL, Algebra 2, you're doing 08.